Nabitý, zvuk jsem zapnul.
Good afternoon. I am sorry it was only half hour, but to have such a nice keynote speaker for the afternoon, I cannot delay the session, and I am extremely happy to present to you Jenny BARNA from SPIRE. I have to say that I don't know nothing about SPIRE. I hope that she's not listening. I have nothing about SPIRE. I Googled. I understand that they have the biggest network. That's why we have here Jenny, that she will tell to us about SPIRE. Just some basic information. Jenny is a launch manager at SPIRE. That's why you follow all. Just 10 dB down the noise if you can. And she did with SSL some advanced system engineering, with orbital science, different propulsion, associated engineering. That's why you are in fact an engineer, which is a very good in between us. We like make jokes with girls, blondes, engineers, which is very good. Just to set up the temperature of the room. Thank you. Jenny, microphone is yours. Welcome.
Is my clicker?
No, the microphone is here. This is a remote control. But because it's PDF, the remote, this is a PDF remote control.
Okay, so you're going to be my driver?
I am ready to be your remote.
Okay. So that should be the... Okay. So the disclaimer that I am an engineer also means that I'm not a communications engineer. I'm not an electrical engineer, not an FCC lawyer, or ITU, you know. So I am going to be approaching this from someone who is a little bit dumb to that side of things. And I'm learning a lot here, and I'm learning a lot at SPIRE. So this is really good that you're hosting this. This is great. All right, so a little bit about SPIRE. We were founded in 2012 by three International Space University students, and it was originally a Kickstarter campaign to launch a 1U CubeSat that students could access to run experiments. So it was entirely educational based. That arm of the company actually still exists today, but we're headquartered in San Francisco, and we have since rebranded from that original educational platform, which was ArduSat, and the company was called Nano-satellite, to SPIRE Global, and we're very different today. Next slide.
Yes, sir.
Oh, thank you. So last year, you may have seen some press on us for the first time. We raised $25 million in our Series A round, and we are growing. We are headquartered in San Francisco still, but we have offices in Singapore and Glasgow. We have about 40 people, and what we're doing now is ship tracking, so AIS, and GPS RO, weather data. And we still have that ArduSat relationship. So we've launched 4 satellites to date, 3 from the International Space Station, 1 on a NEPR cluster launch last year, and that one's still operational. Next slide. Our platform is a 3U CubeSat. We do everything in-house, all our software and hardware. We do have a few suppliers for some subsystems, but all of our integration and software is in-house. The constellation that we are planning will be 20 to 25 by the end of the year, and then 100 plus after 3 years. And we are nominally around 500 kilometers, and the inclination can be all over the place. So hopefully equatorial, polar, and anywhere in between. So small sets. I don't know if you remember what your cell phone looked like in the 80s or the 90s, but to say that today a CubeSat can't do what a much bigger satellite can do is as asinine as saying an iPhone can't do what that thing could do. So, next slide. In 1990, for about $10,000, you could buy this computer, right? So you apply Moore's law, and today, obviously, if you compare the cost and performance, you're looking at 1,000x the capability. And everyone knows this is nothing new, but next slide. The same thing is happening with everything that we put into satellites. So this is one example of a sun sensor. This was in 2006, so not as far back as 1990, but in 6 years, if you can see on the right, that's what it looks like today. Oh, thank you. Not even today, 3 years ago. Where's the button? There we go. All right, next slide. The same thing's happening across the board with what we can actually do in terms of power and bandwidth. It's really across the board. You can apply Moore's law the same way that we've seen it happen in consumer electronics. Next slide. The other thing that's going on at the same time that the technology is hitting this huge ramp up is all of a sudden CubeSats can book secondary space very easily on a lot of different launches every year. So everyone knows on the left, we've got this massive launch industry that used to cost a couple $100 million and still does for government customers. This year, this is a Sherpa ring that Spaceflight Inc. does out of Seattle. They're one of the brokers or integrators that secondary CubeSats will use. But this has something like 80 or 90 secondaries flying on it. So it's going up on a Falcon 9 later this year. And I don't know, I think this is going to be historical. I don't know that there's ever been a launch with this many secondaries on it. But this is going to be kind of the future. I think in the next couple of years, you'll see a company like Spaceflight or Tyvak or ISIS or any of the others booking their own launch vehicles and just dedicating the entire thing to secondaries. So suddenly, it goes from millions and millions of dollars to get to space to a couple $100,000. Next slide. So with the easy access to space and this technology that we can build in-house and is way more capable than it used to be, this is kind of the new launch approach that you're seeing that I would think of as kind of Silicon Valley, but it extends globally. On the top, you have your legacy geosatellite, which if you signed a contract to launch a geosatellite in 2005, you would freeze your design. No more changes. That technology that existed in 2005 would go on your satellite, take 2 or 3 years to build it in a rapid commercial environment. So that's not talking government satellites. And then go ahead and launch it in 2008, 2009. And in 2023, you would have that technology on board from 2005. There's this classic example of the Mars rover. When they first went into CDR, they had a 2-megapixel camera as part of the design. And by the time they were going to ship that thing to launch, I'm not sure what exactly the capability of the camera was, but it was not 2 megapixels. It was like 5, 6, 8, but they couldn't put it on the rover because if you've ever been on a government program and tried changing anything after CDR, it's a monumental effort, huge cost of engineering. Even if it makes sense, it's just not feasible. So, back one. So if we're building and launching every single year, if not faster than that, every 2 months, every 3 months, we can build these things in weeks, and we can launch. There's a secondary opportunity on the order of at least once a quarter, if not once every month. Then you're constantly refreshing your satellites with new technology, the very current, up-to-date technology, and just iterating that design. So in 2023, your technology is going to be 20 years better than these legacy satellites. Next slide. So this is kind of the new economic landscape, and everyone's been talking about it, but if you have the low cost to build and launch the satellites, the rapid access, meaning all the opportunities to go as secondary, all of a sudden, well, then the next step of that is if it's so low cost and so easy to do, all of a sudden you drop your risk tolerance, or you raise your risk tolerance. So where if you were building a $1 billion satellite,